Good afternoon, girls. I have prepared revision of Module 1 chapter, and in that, the first topic I'm going to discuss here is mathematical analysis of non recursive algorithm. So, the theory part, you know, right? How do we analyze a non recursive algorithm? Non recursive algorithm, in the sense, if you have constructs inside the algorithm like for loop, while loop, how do you find out the time efficiency of such algorithm? And in that in the textbook they have given one such example of to find out the largest value of the array, or to find out the largest value in the list, largest value in a list of n numbers. Okay, so basically in this algorithm you are supposed to find out maximum element of the array. Okay, so for that what we require, first we're going to take an array. Okay, like this. So I have taken an array and the size of the array is 7 here. Since the lower bound starts with 0, it has to end at the index value n minus 1. Okay, so we have total 7 elements. It is starting with the lower bound 0, hence it ends at the higher bound 6. Okay, that is n minus 1. So what is the logic behind this is to find out maximum element is, so very first element is 20, right? So here a of 0th index value, we have a content called as 20. So 20, a of 0, we have a content called as 20. What I do is, I'm going to copy this 20 into a variable called as maxval. That is the first step. Okay, so the first step is what? I'm going to create an array, and inside that array, at the 0th index value, we have a number called as 20. Since in the given array we are supposed to find out the maximum number, no, maximum element. So for that what I do is, I'm going to copy the first element of the array, that is 20, into a variable called as maxval. That is the first step. Okay, so name of the array here is a, hence a of 0 is 20, and the same value I'm going to copy it to maxval. Okay, after that what I do is, since we have copied the 0th index value to a max value, I'm going to start from the index value 1 now. Okay, because we have copied 20 to a variable maxval, hence I'm going to start with the index value 1. Okay, so every time I'm going to compare a of, let us take the first element, I'm going to compare a of 1, is it greater than maxval. Okay, so you can observe here, a of 1 is nothing but this index value, and the content of this is 40. So 40, is it greater than maxval? Maxval is what? 20. So 40 is greater than 20, condition is evaluated to true. So if the condition is evaluated to true, we are supposed to update the value of maxval. Okay, so we are supposed to update the value of maxval to a of 1. Okay, so like this, maxval is now is equal to 40. Okay, so now after that we should go to the next element of the array. So next element is what? This one. Next element of the array is 2, a of 2. So now here in a of 2, the value of a of 2 is 5, and now max value has been updated to 40. So again perform the same operation. So this one, a of 2, is it greater than max val? No, 5 is not greater than max val. If this is the case, no necessity of updating the max val. Okay, so next we move to the next value of the array, and it is a of 3, is it greater than max val? A of 3, we have 17. At the index value 3, we have the content 17. Is it greater than 40? No, it is not greater than 40. So no necessity of updating the max value. Now I move to the next value of the value of the array, that is a of 4, and at the index value 4, we have content called as 8. We have an information, or we have a information, or some element in the array, that is 80. We should check whether 80 is greater than 40. Condition is evaluated to 2. When the condition is satisfied, you are supposed to update the value of max val. So now max value has been updated to the value of 80. Okay, so max val has been updated to the value of 80. Okay, so again you should increment value of I, because until you reach the end of the array you are supposed to traverse. So next index value is a of 5. A of 5, is it greater than max val? A of 5, we have 10. Is it greater than 80? No, condition is evaluated to true. No necessity of updating value of max. So go to the next element of the array, that is a of 6. A of 6, is it greater than max val? Yes, condition is evaluated to true. You should update value of 90 to the max val, and then since we reach the end of the array, a of 6 is the last index value, and hence we reached the end of the array, you are supposed to update the final value of the max. Okay, final max value tends to be 90. Okay, so now observe the tracing proper logic. You should understand the logic properly. So here we started with the index value 1. You can observe here. Why? Because so the 0th index value, we're going to directly store it in a variable called as maxval, and we traverse from the index value 1. From 1 we move to 2, from 2 to 3, 4, and then 4 to 5 we moved, and from 5 to 6, and 6 is the last index value, final index value. So how do you write the algorithm? So in the algorithm only you are supposed to write these 4 steps. So first what we did, so first element of the array we directly copied into a variable called as maxval. Okay, and second, after copying the first element of the array to the maxval, now for comparison you are supposed to traverse from 1 and you will be ending at n minus 1. Okay, so 1, n minus 1 is nothing but 7 minus 1. 7 minus 1 is equal to 6. Okay, so 1 to 6 you are supposed to traverse, and for each of the element of the array what we are supposed to compare, if a of this particular value, is it greater than max val, that you are supposed to compare. Okay, so the first element we have copied into max val, hence you are supposed to traverse from the index value 1 till you reach the end of the array. So in the first iteration I value will be 1. Okay, so a of 1, is it greater than the max val? Max val is a of 0. Okay, if the condition is evaluated to true, what we are doing, we are updating this a of I value to the max val. Okay, and after reaching the end of the array, whatever the value we have in the max val, that should be returned to the main function. So that is the logic, and that we have, and this is how we write the algorithm for the logic I just now explained.